Hello everyone. Today, we're going to learn about one-way repeated measures ANOVA and how it can be applied in quantitative research, particularly in studies where the same group of participants is observed repeatedly over a period of time. We'll also explore how to perform this test using Jamovi, a user-friendly statistical software. Please note that the voiceover, as well as the sample, problem, data, analysis, and interpretation, are generated by an AI for demonstration purposes. Let's get started. Alright, let's talk about repeated measures ANOVA. This is a statistical test we use when we want to compare the means of three or more related groups. Now, what do we mean by related? It means we're looking at the same participants measured multiple times, like tracking their responses across different time points or conditions. Think of it as an extension of the dependent t-test. Instead of comparing just two related groups, repeated measures ANOVA allows us to look at several. That's why it's also called a within-subjects ANOVA, because all the data comes from within the same group of people. To use this test, we need a continuous dependent variable, something we can measure numerically, like scores or ratings, and a categorical independent variable, which represents the different conditions or time points we're comparing. In research, this is especially useful when we want to see how something changes over time, like students' performance across quarters, or in our case, teachers' perceptions of a program's effectiveness. Now let's talk about longitudinal studies. This research method is used when we want to observe the same group of individuals over an extended period of time. The key idea here is that we're not intervening or manipulating anything. We're simply watching how certain traits or behaviors change naturally. For example, if we're studying how students' attitudes toward bullying evolve throughout the school year, we would collect data from the same students at different points in time. This allows us to track patterns and developments that might not be visible in a one-time survey. Ungvarsky, 2023, emphasizes that longitudinal studies are especially useful when we want to understand long-term trends or the progression of behaviors. It's a powerful method for educational research because it helps us see how experiences and environments shape individuals over time. Let me walk you through the pseudo-study we're using to understand how repeated measures ANOVA works in real research. In this scenario, a local high school has launched a comprehensive anti-bullying initiative called Panther Pride, which stands for Personal Responsibility in a Diverse Environment. The goal is to reduce bullying and improve school climate. Now, the school administration wants to evaluate how effective this program is, but not just from student outcomes. They're focusing on the teachers' perceptions, since teachers are directly involved in student interactions and can observe behavioral changes over time. To do this, the same group of teachers complete a standardized questionnaire at the end of each academic quarter. This allows us to track whether their views on the program's effectiveness change as the year progresses. Since we're collecting data from the same participants multiple times, this is a perfect setup for a repeated measures ANOVA. This method helps us determine if there's a statistically significant change in perception across the 4 quarters. In this study, we're focusing on how teachers perceive the effectiveness of the Panther Pride anti-bullying program over the course of one academic year. We're asking 2 main questions. First, we want to know, how effective do teachers think the program is at the end of each quarter? So we're looking at their ratings in quarter 1, quarter 2, quarter 3, and quarter 4. This helps us understand how their perceptions may shift as the program continues. Second, we're asking, is there a significant difference in those perceptions across the 4 quarters? In other words, did their views change in a meaningful way over time? By answering these questions, we can evaluate not just whether the program is working, but also how its impact is perceived by those who interact with students daily, our teachers. To guide our analysis, we've established 2 hypotheses. The null hypothesis states that there is no significant difference in teachers' perceived effectiveness of the Panther Pride program across the 4 quarters. In other words, if this hypothesis holds true, it means teachers' views remained consistent throughout the school year. On the other hand, the alternative hypothesis suggests that there is a significant difference, meaning teachers' perceptions changed over time, possibly improving or declining as the program progressed. To test these hypotheses, we're using a significance level of 0.05. This means we're allowing a 5% chance of error in rejecting the null hypothesis. If our p-value falls below 0.05, we'll consider the change in perception statistically significant and reject the null hypothesis in favor of the alternative. Let's now look at how the study was conducted. We had 35 high school teachers participate. These are the same individuals who were observed throughout the entire academic year. This consistency is important because it allows us to track changes in their perceptions over time without introducing variability from different participants. To measure their perceptions, we used a standardized questionnaire. This tool asked teachers to rate the effectiveness of the Panther Pride anti-bullying program on a scale from 0 to 100, where 0 means not at all effective and 100 means extremely effective. This gives us a continuous dependent variable, which is ideal for statistical analysis. As for the procedure, each teacher completed the questionnaire at the end of every academic quarter, so that's 4 times in total. This repeated observation of the same group is what makes the study longitudinal and suitable for a repeated measures ANOVA, which we'll discuss in more detail shortly. To help interpret the scores from our questionnaire, we've established a descriptive range that categorizes how effective the Panther Pride program is perceived to be. Scores from 81 to 100 are considered highly effective, meaning teachers see the program as having a strong impact. Scores from 61 to 80 fall under effective, indicating a positive but slightly less intense perception. 41 to 60 is labeled moderately effective, suggesting mixed or average views. 21 to 40 is slightly effective, where the program may be seen as having minimal impact. And finally, scores from 0 to 20 are interpreted as not effective, showing little to no perceived benefit. This scale helps us translate numerical data into meaningful insights, making it easier to understand how teachers are responding to the program over time. Presented on your screen is the data showing how teachers perceive the effectiveness of the Panther Pride anti-bullying program across the 4 academic quarters. As you can see, the scores reflect how their views evolved over time. This data is crucial because it helps us understand whether the program had a growing impact, remained consistent, or showed any fluctuations in its perceived effectiveness. We'll use this information to analyze trends and determine if the changes are statistically significant. Let's now analyze the data using Jamovi. Please open the Jamovi software. Now, let's encode the data into Jamovi. If you already have the data in a spreadsheet, you can simply copy and paste it into the Jamovi data grid. Alternatively, you can import the file by clicking on Open and selecting your spreadsheet. To make our dataset clearer and more meaningful, we renamed several columns to represent quarterly data. Column B is now labeled as Q1, indicating it contains data for quarter 1. Column C becomes Q2, representing quarter 2. Column D is renamed to Q3 for quarter 3, and finally, column E is labeled as Q4, representing quarter 4. This renaming helps us quickly identify which data corresponds to each quarter, making analysis more intuitive and organized. Now that our columns are clearly labeled as Q1 to Q4, representing each quarter, we're ready to begin analyzing the data. Let's go ahead and click on the Analyses tab located at the top of the Jamovi interface. This will open up a variety of statistical tools and options we can use to explore patterns, compare groups, and draw meaningful insights from our quarterly data. After clicking on the Analyses tab, we now go to Exploration, and from the drop-down, we select Descriptives. This feature allows us to quickly summarize our quarterly data. It provides key statistics such as the mean, median, standard deviation, and range, which help us understand the distribution and central tendencies of each quarter's values. Now that we're in the Descriptives panel under Exploration, we'll go ahead and highlight the variables Q1 to Q4. With Q1 to Q4 highlighted, we now click the right arrow to move these in the Variables box. This tells Jamovi that we want to include these columns in our descriptives analysis. Once added, Jamovi will automatically generate the statistical summary for each quarter, giving us a clear overview of how the data behaves across time. To assess whether our quarterly data follows a normal distribution, we scroll down to the Tests of Normality section in the Descriptives panel. Here, we check the box for Shapiro-Wilk. This test helps us determine if the data in each quarter, Q1 to Q4, is normally distributed. Here are the results from our descriptives analysis. For each quarter, Q1 to Q4, we can now see key statistics such as the mean, standard deviation, minimum and maximum values, and more. These help us understand the overall behavior and spread of the data across time. Below that, we also have the results of the Shapiro-Wilk test for normality. A p-value greater than 0.05 suggests that the data does not significantly deviate from normality. As you can see on your screen, I've already transformed the data to prepare it for analysis. I won't be showing the transformation process here anymore to keep this presentation focused. However, if you'd like to learn how to transform data in Jamovi, I recommend watching the video lecture titled Group Frequency Distribution, Transforming Data in Jamovi. That video walks you through the steps in detail and will help you understand how to properly structure your dataset for analysis. Let's click on the Analyses tab once again. From the list of options, we go to Frequencies and then select Independent Samples. This feature allows us to examine how different groups compare based on our transformed data. First, we move the variable Q1 to the row box. This tells Jamovi that we want to analyze the frequency distribution of Q1 data across different categories or groups. By placing Q1 in the row field, we'll be able to see how the values are distributed and how often each value appears within the dataset. Next, we move the variable Q1, transform 1 to the column box. This step tells Jamovi that we want to analyze how the transformed Q1 data is distributed across the categories defined in the row variable. To better understand the distribution of our data, we now go to the Cells section in the Analysis panel. Here, we check the box for percentage and specifically select row. This setting allows us to see the percentage breakdown within each row, helping us interpret how the values in Q1, Transform 1 are distributed across the categories in Q1. What you can see on your screen is the result for question 1. What is the level of perceived effectiveness of the Panther Pride anti-bullying program as rated by teachers at the end of Q1? This is the data that will be encoded for frequency and percentage. Repeat the process for SOP 1.2, 1.3, and 1.4. I will not show it anymore here in the simulation because our focus is the repeated measure ANOVA. Again, you may watch the video, Group Frequency Distribution, Transforming Data in Jamovi. Let's go back to the research questions, and in this presentation, we will be answering statement of the problem 1. The next few slides will present the tables that address SOP 1.1, 1.2, 1.3, and 1.4. Please note that I haven't included the analysis or interpretation of the results in this presentation. If you'd like to see examples of how to analyze descriptive tables, you may watch the video lecture on paired t-test, independent t-test, or one-way ANOVA, between subjects design. Here is the possible table presentation for research question 1.1. Please note that the frequency and percentage values were derived from the contingency tables, while the mean and standard deviation were obtained from the descriptives table. The possible table presentation for research question 1.2. For research question 1.3, again, please note that the frequency and percentage values were derived from the contingency tables, while the mean and standard deviation were obtained from the descriptives table. And the possible table presentation for research question 1.4. Now, let's analyze the data to answer research question 2. Is there a significant difference in the teacher's perceived effectiveness of the Panther Pride anti-bullying program across the 4 quarters? To answer this, we will be using a one-way repeated measures ANOVA. This statistical test is appropriate because we are comparing the same group of teachers' ratings across 4 time points: Q1, Q2, Q3, and Q4. It allows us to determine whether there are statistically significant changes in their perceptions over time. To begin our analysis, we click on the Analyses tab at the top of the Jamovi interface. From the list of options, we select ANOVA and then choose Repeated Measures ANOVA. By default, Jamovi labels the repeated measures factor as RM factor 1 or repeated measure factor 1. In our sample case, we'll rename this to quarter since we are measuring the same group of teachers across 4 quarters. This label will help us clearly identify the time points in our analysis and make the output easier to interpret. Now that we've labeled our repeated measures factor as quarter, we proceed to highlight the variables Q1, Q2, Q3, and Q4. These represent the teacher's perceived effectiveness ratings for the Panther Pride program across the 4 quarters. By selecting these variables, we're telling Jamovi to include them in the analysis as the levels of our repeated measures factor. After highlighting Q1, Q2, Q3, and Q4, we now click the right arrow to move these variables into the repeated measured cells. You can see on your screen that Q1, Q2, Q3, and Q4 have now been successfully transferred to the repeated measures cells section. The result of the one-way repeated measures ANOVA is now displayed on your screen. This output shows whether there is a statistically significant difference in the teacher's perceived effectiveness of the Panther Pride anti-bullying program across the 4 quarters. We focus on the F value, which is 198.145, and the P value, which is 2.13 times 10 to the negative 42nd power. Since the p-value is significantly less than 0.05, this indicates a statistically significant difference in perceptions across the quarters. Since the p-value is lower than the alpha level of 0.05, a post hoc analysis is necessary to determine which specific quarters differ from each other. Click Post Hoc Tests to proceed. You'll notice that the default correction method under Post Hoc Tests is Tukey. While other options are available, we'll stick with Tukey for this analysis as it effectively identifies pairwise differences. Click Quarter. Click the right arrow to proceed to the next step. Results are now displayed. These show the pairwise comparisons between quarters using the Tukey post hoc test. Significant differences are typically marked with asterisks or bold values, indicating which quarters differ in terms of perception. In the next slide, I will show the actual simulation in Jamovi. Please watch closely how the steps are performed. I will no longer speak, so you can focus fully on the process. Next slides, table presentation, sample analysis, and interpretations for SOP2 research question. Is there a significant difference in the teacher's perceived effectiveness of the Panther Pride program across the 4 quarters? We will present the statistical results, followed by a sample interpretation to help understand the implications of the findings. In the upcoming slides, we will follow a consistent flow. Each slide begins with a table presentation showing the statistical results. This is followed by a textual explanation that summarizes what the data reveals. Finally, we move into a discussion that interprets the findings, drawing insights from both observations and relevant literature. Table 5 presents the significant differences in teachers' perceived effectiveness of the Panther Pride program across 4 academic quarters. A one-way repeated measures ANOVA was conducted to determine whether there were statistically significant differences in teachers' perceptions of the effectiveness of the Panther Pride anti-bullying program across the 4 quarters. Table 6 shows the result of post hoc comparisons using the Tukey HSD test following a significant one-way repeated measures ANOVA. Based on the findings, the Panther Pride program has shown a meaningful and positive influence on the school community. Teachers consistently observed improvements in student behavior, including a noticeable reduction in bullying incidents and an increase in respectful and empathetic interactions among learners. These changes were affirmed through teacher insights and interviews, which highlighted the growing sense of accountability and peer support among students. The program's consistent implementation, coupled with active teacher involvement and a supportive school environment, contributed to its success. As the school year progressed, the values promoted by Panther Pride became more deeply embedded in the daily experiences of both students and educators. This demonstrates the program's potential not only to address bullying, but also to foster a culture of care, responsibility, and mutual respect within the school. Thank you. I really hope you learned from this lecture.